So to motivate the algorithms that we're going to talk about in this unit, let's go back to the Marvel data again. So here's 3 superheroes. We're going to call them Black Widow, Spider-Man, and the Hulk. Remember that they're connected in the graph, in the original graph, by an edge if the comic book character is in a particular comic book. So there's a set of comic book characters and a set of comic books, and we add links like so, depending on which comic book characters are in which comic books. Now, we're often interested in connections between the individual characters. So up till now, we said that there's an edge linking, say, Black Widow and Spider-Man, if and only if there exists a comic book such that Black Widow and Spider-Man both appear in that comic book in the original data set. So there's really 2 different graphs that we're working with here. There's the graph between comic book characters, and then there's the bipartite graph between comic book characters and comic books. Now, this edge appeared, as long as there was at least one book they had in common, even if that book had a zillion comic book characters in it, and it was the only book that they were in together, as opposed to, let's say, it's like Batman and Robin, which is probably not Marvel. But anyway, 2 comic book characters that appear together very often, they would also just get a link between them, and that doesn't seem quite right. What we'd like to do is put a weight on this edge, where the weight equals the number of books they co-appear in. All right, so what you need to do is compute connection strength. Write a Python program to read the Marvel graph and put a strength value on each link.